Unit 4, Lesson 5. In this portion of the lesson, we'll be talking about corresponding parts of congruent triangles are congruent, or Cpctc. So, right now we've been dealing with proving two triangles congruent. However, you may be asked to prove that a pair of corresponding sides, or corresponding angles, within those two triangles are congruent. You could be asked to prove some other relationship. So, for example, you may be asked to prove that two lines are parallel, or that a given segment is an angle bisector, or that a certain point is a midpoint, among other things that you may be asked. So, in order to do this, we're going to use corresponding parts of congruent triangles are congruent. Before we can use that, though, we must first prove that the two triangles are congruent. So, corresponding parts of congruent triangles are congruent. So what does that mean? So that means if I have two triangles and let's say I've proven them congruent, so by hypotenuse leg, I know that these two triangles are congruent. I can then talk about any other part of the triangle, because if these two triangles are congruent, then their corresponding parts need to be the same. So again, I've already proven these two triangles here congruent by hypotenuse leg, and so then I can talk about this side and this side. Or I can talk about this angle and this angle, because these correspond with one another. So because these two triangles are congruent, which I have proven, I can now talk about the other parts, meaning sides and angles, right? Sides and angles are being congruent as well. So let's apply this. So first things first, if we're asked to prove something other than the two triangles being congruent, this is a hint that you may need Cpctc. Depends on the proof. Again, that varies. So let's see. So again, our first step is to prove the two triangles congruent, and let's annotate or mark our diagram with the given information. So they gave us angle 1 is congruent to angle 2. They gave us angle A is congruent to angle E, and they told us that C is the midpoint of AE. So I know that this piece and this piece is the same, and let's write our methods that we have: side, 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 angle, angle, side, angle, and hypotenuse leg. Well, these are not right triangles, so hypotenuse leg is out. They gave me two angles, so I know that side, 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 and side, angle, side are out, and there's no common side between these two triangles. So I'm down to angle, angle, side, or angle, side, angle. Well, I have two angles and the side included or in between them, so we are going to use angle, side, angle to prove these two triangles congruent. So I've set up my table, I've put my given information in there. Currently I have an angle and an angle, which means I need a statement relating to the side. And because they gave me C as the midpoint of AE, I know that AC is congruent to CE, and that is by definition of a midpoint. And so now I have a side, and again, I already identified my method up here, so I can say that triangle, okay, now I need to write that congruency statement. ACB, ACB is congruent to triangle ECD. And notice I put them in corresponding parts. A corresponds with E, C corresponds with itself, and B and D are also the same. So by angle, side, angle. And so now let's look. BC is a part of this triangle, which corresponds with DC, which is a part of the other triangle. And since I've already proven that the two triangles are the same, I can now say that BC is congruent to DC by Cpctc. Corresponding parts, meaning these two sides, correspond with one another, of congruent triangles. I already showed that in step 3. So therefore, because these triangles are congruent and because these parts are corresponding, these two pieces must also be congruent. And that's how we apply Cpctc.